Hello and welcome to TechKnow Tuesday, the semi-weekly podcast about the first tech challenge and other things related to science and engineering. My name is Kendrick Bender and I'm here along with
Minnie and Phil.
AJ Stavopoulos.
Today we are going to be talking about the Rosetta spacecraft.
Fun with brushless DC motors underwater.
And a lot about the Annapolis qualifier.
So I think we should hear all about the Annapolis qualifier for FTC, which the TechKnow has played twice because they didn't like the first time.
No, we were practicing the first time. Yeah, so basically, for those of you who are there, the first day didn't quite go so well. We got like 22nd place. And then it turns out the second day, after lots of modifications through the night, we ended up getting first place, Alliance Captain, and all that good stuff. So it was probably the most unanticipated comeback of all time.
Describe the mood on Saturday.
Saturday night, it was, I'd say it's mixed between team members. There was a lot of confusion as to where we were meeting up. Like, tons of confusion.
That's because you guys stayed in.
And then eventually we were like, okay, we're just going to go and we're going to work on the robot. And then finally everyone sort of figured out what was going on. And so we were able to
So confusion
sort of
and,
it up.
I mean, to tell you the truth, at least some of us, at least I was anyway, we were kind of expecting us to do not so well the first day to see the kinks because we hadn't really done much drive practice. We didn't get to test our design all together. Like, we did lots of individual tests, but all together we didn't really get to.
We did end up making lots of changes to the robot overnight that ended up making a huge difference the second day and was able to let us do the things we could do at least decently well. Because the first day we were more or less trying to do everything and pretty much nothing worked.
Yeah, and then the second day, I thought the second day was pretty interesting how we teamed up with different people. And the difference between the day before where we were the weaker link every time we were hooked up with someone else. And it was kind of interesting how we were actually equal with our alliance partners for the second one.
And the second day we also did not get a penalty for tearing up the field.
Oh my gosh. Alright, so going into that,
If you recall episode number 2 or 3, I predicted that those white wheels would cause trouble. And I said, I'll be very surprised if they don't make some ruling or do something for the use of the unmodified wheels. Now, we sanded ours, and I know you initially sanded yours, but at the time I didn't think you'd really taken a lot of the sharpness off of them.
well, we took the sharpness off the edges, but we found that the issue was inside the actual treads between teeth, so to speak. So we went through and actually Dremeled all the corners off of the wheels. I would highly recommend people do that.
We took a Dremel and sort of beveled. I think on one of the wheels we only did the leading edge, so it would only protect us whenever we were spinning forward, just because of the time constraints we had.
We didn't have all night.
But I think that was a huge change that we made because the first day they tore up the field pretty bad. And I had talked to one of the refs there, and he said he had talked to one of the people on the game design committee, and they were going to outlaw those wheels next year. So,
Nice.
because of the field damages they've already seen this year, and I think that's probably a good thing.
Yeah, other than the fact that, I mean, you compare these to tracks, they have more traction than tracks. It's awesome.
Yeah.
Especially whenever they sink into the foam, it's just like, can't move me. I mean, we had Omni wheels in the front, and we had people try to kick us sideways, and it wasn't doing much.
But whenever
So get them while you can, right?
Whenever you get up against something that can't be moved, they tend to tear up the field just a little bit.
Yeah, so we ended up putting, I don't know, like 1/4-inch deep ruts, maybe even a little deeper than that into the field.
So how did you solve your uneven wheel issue?
Oh, so that's an interesting thing. We actually...
This is not exactly the suggested way of fixing it, and...
So, what happened was, one of the front wheels was lower than the back wheels. And so it was teeter-tottering between the two, like if you have a chair.
Actually, one of the front wheels was higher than the other front wheel, so it was kind of like...
Back and forth. And then we took a drill and extended the hole upward a little bit. and then it's basically almost like...
Because it wasn't a driven wheel, so it didn't
It wasn't a driven wheel, so
floating.
so
It wasn't
really
a driven wheel, and then on top of that, we also took the bushing out.
Yeah. So it's more of a...
That's the part that I would really suggest against, but,
Yes.
you know.
But, hey, it worked really well because we ended up hanging... Every time we wanted to hang, we were up there and hanging. Even whenever we had, like, 10 seconds left.
So it definitely worked for a quick fix.
Yeah, for sure.
So 4 wheels on the ground, highly overrated.
Highly overrated.
4-wheel drive, who needs it?
But I think suspension, especially now that we're allowed to use springs, might be something to return to again. Because I know we did it the first year of TechKnow Clovers with rubber bands, and it actually worked pretty well.
I've learned a lot about torsion springs this year. Torsion springs are very cool. You know, the ones that look like little worms with... I don't know how to describe it. Anyway, they're the things that normal springs pull in and out, torsion springs twist.
Yeah.
So they give you tension. And, you know, it looks like there's quite a bit of science behind them, because just going to McMaster to choose one, you get all these different variables. You know, the angle that the two wires make when it's relaxed, and that tells you how far you can rotate it to get its design torque. You know, some are 90 degrees, 120, 180, 360. And then there's the diameter of the wire, there's the number of turns, there's the diameter of the hole once you fully compress it, and they all affect the overall force. You know, so in the same area you can get anything from, you know, a couple of pounds to 40 pounds of torque, 40 foot-pounds of torque out of these things.
It's probably because springs are a pretty technical piece anyway.
Yeah.
So if you're ever thinking of using them, it would be worthwhile to, you know, pre-buy 2 or 3 different ones in the kind of range you're looking at, and then experiment with them.
Put in some research as well before you go buying them.
When they're cheap enough, you just got to make sure you get the right thing.
One thing I will say I was surprised about at the competition was how consistent our autonomous was. I think we broke our record this year for like the most consistent our autonomous has ever been.
I will say that was an impressive program, because he is the first time we've ever had it, so that he programmed it, we tried it on the robot, and it worked the first time over and over again. We've never had that happen before.
And I think it only missed the crates once or twice.
Once was because there was so much light hitting it. It was right before sunset, and it was just blaring in there. And so as soon as it started, it just kicked it out.
Well, I think the game design committee, I think they made it easier for us this year in general by putting the beacons down on the ground, by putting putting a black background all behind them, you know, and making it so that
because they realized
it was easy to point to. I mean, previous times hanging those things up in the air on the tube, the ring racks. I mean, that was bedlam. You had no idea what was behind them. You had no idea what other lights. Your sensors are pointing up high, so you're more prone to ambient lighting. Yeah,
they were interesting last year.
Yeah.
They did make it. I think they saw that not many people could do it at all. I mean, there was one team that did a Worlds twice, and because no one. It was more worthwhile to do other things that are autonomous by the end of it.
Yeah, and which explains why you had so much success on yours, because you got that little slit giving the story away here.
No.
Yeah, you know.
Come on.
That doesn't let any other light in. That's a pretty cool idea.
Brilliant. Tim, I will give Tim a lot of credit on that one.
Pretty nice. So as long as your mechanical alignment on your robot is consistent and stays there and doesn't rattle around, then you're good.
Before we move on, I'd like to give a shout out to 6100, who was the winning alliance captain of our first one, and also
wait, don't jump in. They were the only reason you won a game on the Saturday, right? When you played with them.
Did we play with 6100? I thought we played with.
Not sure.
It's possible. He might be right. 8221. They're an impressive team. I really liked working with them. They were great to work with, and they had an amazing robot. So
cool.
Shout out to TechBrick. They displayed some gracious professionalism, let us borrow their wheels. They were expecting us to just take it home with us and then send it back later.
So
but we ended up
what did they loan you?
We didn't.
Tetrix wheels, normal ones, because
okay.
we didn't take any with us because we're like, we don't use them on our robot this year.
Good note to Phil. Make sure we take some Tetric wheels
for sure, because they might yell at you even if you fix the edges.
Yeah.
So.
I mean, we haven't. I mean, since the first days of testing, we haven't, caused any damage to the field. So we're hoping that
the way you need to test it, turn towards the wall and just start driving. Because that's what happened with ours.
Right.
And then we just kept driving and driving and driving. And you can see the back end kind of going like this. It was interesting.
So, what would you say were some things that you weren't expecting at the competition that you encountered, either strategies or gameplay or whatever?
I was expecting a ton more defense. There was, other than us, 0 defense until the finals match. I was kind of, I don't know, it kind of
So was everyone
surprised
intent
me.
on scoring? Was that what it was, or what?
Yeah, everyone was like, oh, I want to score blocks, which I was kind of interested because normally, especially in Maryland qualifier, there's a ton of defense, and there's lots of contact, and even the defense until the very final match, like, we would play defense here and there, but we wouldn't be, like, bashing people.
Oh, that's not what I heard.
No, we would sit there and they bash into us, like, 12 times, tried to move us. And
I've talked to a referee, and he told me that you guys were fairly aggressive on your defense.
It was, I guess it was actually kind of normal to see that there were only a few robots that really stood out as being really good, but those few that stood out as being really good were really good.
Yeah.
They were ones that, could score lots of blocks during teleop, and they could do both endgame elements.
So a really good scoring block robot, how many rounds of scoring would they do?
well, I know 8221 would score, I think, 2 rounds of 4 in each edge basket.
Wow, that's pretty amazing.
And they keep going and scoring until about 18 seconds, which scared us, because normally you can't hang with only a few seconds left. And so they just run over, hook on, and just lift, which was...
They have a really fast lift mechanism for the end games. So
it's genius, but we should not give that away.
So they can go up. They can score like crazy right up until the last second, and then go.
Yeah, they have pictures of them with 2 seconds on the clock, have their arm up, 1 second on the clock, they're lifted. So.
Now, one interesting robot I saw on the on the First Tech Challenge Facebook page is, I think this was actually the Maryland page. There was a robot that, after it would hang, it actually has a piece of its arm that comes out and acts as a second hang-up bar for the other robot to hang from. Like, they actually have a pipe on the front of their arm that extends out from their robot.
So they hang off the other person.
So that the other robot can actually hang on them, just like the...
You can't do that, I thought.
Yeah, you can.
You can? As long as you're not touching the ground.
Well, yeah, you can't be touching the ground, and you have to be on your side of the bridge.
Yeah,
Interesting.
which it would be because it comes
But I
out
wonder if anyone
the
took
front
advantage
the
of
robot.
that.
I didn't see it.
Because you'd have to have a lift mechanism that didn't require you to hang. You'd have to be able to be hanging off to the side, or, know what I mean? By hang, I mean hang vertically.
Mm-hmm.
Mm-hmm. Swing low.
Yeah, because a lot of the ones that I saw, one of the interesting ones I saw was it would push down a lot of C channel, actually. It would just shove it down, so it would lift itself up, hook on, and then drop itself.
Oh, that's clever.
Yeah.
I like that.
The only downside I see with that is you have to be like, right, dead on, and if you're a little bit off, you'll be off to the side and you could tip. And
Right.
but I thought that was pretty cool.
So, fun with brushless DC motors. So, for the MATE underwater robotics team, we've always our big challenge is to find motors that we can use on the robot. Naturally, seeing it's an underwater robot.
Well, that and the fact that it has to be 12 volts.
Yeah, that's 2 fairly serious limitations, because the underwater part means that it's really hard to make a totally sealed motor because it has a rotating shaft of some sort. We did it a couple of years ago with a magnetic coupler, but this year we wanted to go more powerful, and we thought we were going to be able to run 48 volt systems, but then we found out we didn't qualify for that competition, so we had to go back to 12 volt, which means you're trying to pull 10, 20 amps down a long cable, and you don't get a lot of voltage left at the end, and you need a motor that can generate some power. That's
We
also
now have
waterproof.
it.
Yeah, so did a bit of research and have found a brushless DC motor that's got about the right sort of RPM power current requirements, and we just started making a mock-up.
See, I think that we should go like 30,000 RPM and tiny low propeller and see how that works.
Okay, underwater stuff. Okay, here's a little fact you probably don't know. In the air, the drag on your body, or the drag on anything that's moving, is proportional to the velocity. So if you double the velocity, you double the drag.
Yeah.
Underwater, you double the velocity, you square the drag.
Oh.
So the faster you move underwater, the more the exponentially proportional the drag is, which means the more force you have to put in it. So that's why most things that happen underwater happen slowly. So having a 1,000 RPM propeller and having a 10,000 RPM propeller, even if you were trying to put the same amount of power into the water, you would need a lot more power on the one that's running faster. So, more RPMs do not help you. That's why the big submarines, they go... that way they don't burn power. Okay? So the trick was to find a brushless DC motor, and you're going to learn all about... What did we learn fun about brushless DC motors?
Calibration. So much fun. But it was interesting. I like how the fact that they're completely waterproof by themselves.
Yeah. No moving electrical joints.
Nope, just really, really cool magnets.
And so the calibration, that was all about the motor controller, not the motor itself.
Yeah, that was...
And what did you find out about motors?
Brushless motors beep. They make noises.
They can be used as a speaker.
They play songs.
Oh, he wants to play a song with his motor now.
Now that I want to see.
Oh wait, we can have a brushless motor that goes do 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 as it's cruising along.
We just have a random motor sticking out the top of our robot.
Playing the flight of the Valkyries, yes.
All right.
Kind of hilarious.
So I guess we're now in the process of building a rig to measure the force
and the current.
Again?
and the current. We're building a good one.
Building a good one this time.
Yes. The last one was wooden and
not good.
interesting.
Dubious measurement potential.
That's a nice way to say it, Phil.
Yes.
I think that's all the time we have for today. So, on behalf of all of us here at TechKnow Tuesday headquarters, have a nice day.
See ya.